Well, Daniel just demonstrated how easy it is to build an application with NextMove using the router solver and customizing the constraint to the needs of your business. And what I will demonstrate is a different kind of solver, which is called a MIP solver. And MIP solver solves MIP problems, MIP, which stands for mixed integer problems, or sometimes also referred to as mixed integer programming. And mixed integer problems is a class of problems which is used a lot in optimization, and there exists a lot of algorithms that can create great solutions in a reasonable time for real-world sized problems. And for that reason, we think at NextMove it's important that being a tool for decision engineers, we need to expose this tool such that applications can be built quickly, customized for the needs of your business. Now, before I'm going to demonstrate how we have embedded MIP solvers, I will explain the puzzle that we are using to demonstrate this. And the puzzle that we have is something that's is based on something that we use in our branding a lot, which is rabbits and bunnies. And we care a lot about our rabbits and bunnies. We want them to be happy. And our bunnies can only be happy by giving them the correct meals. So we're going to try to optimize their happiness by serving them the right meals. And we can't just give them any amount of meals. We are limited by the ingredients that we have in stock. And so we're going to create solve a puzzle where we try to give them the right meals, optimize their happiness, but do not create more meals or serve more meals than that we have in stock or ingredients in stock. So let me give you a little example with some data to make it a bit more concrete. We have two types of meals and two types of ingredients that we can use to serve. We have endives and we have carrots. We have 12 units of endive in stock and 5 units of carrots. We have two kinds of meals. Meal A serving 1 carrot and 3 units of endive, and it creates 6 units of happiness. And the happiness that the bunnies express are binkies, which are jumps in the air. If you have a rabbit at home, you might have seen them execute one. The other meal, B, consists out of 1 unit of carrots and 2 units of endive and only creates 5 binkies. Now, the question that we're trying to solve here is how many of A and how many of B, such that we create the most binkies, but we don't serve more than that we have in stock. Classical problem, very small problem, but it demonstrates how we have implemented the mixed integer problem and the mixed integer solver. So when I scroll down a little bit on the screen, you can see the syntax, how it's implemented. And I will, in a minute, go to the real application. So we have to create a model. We have to express our problem in terms of variables and constraints. A variable that we want to introduce is how many meals of A do we serve. That's how we do it. We make a new int, which is a variable for which the algorithm needs to assign a value such that it maximizes the happiness. And for B, we have to tell it it's a maximization problem. We have to say in the objective, what are we trying to optimize? Well, if we serve 1 meal of A, it creates 6 binkies. And if it's meal B, it's 5 binkies. And we introduce 2 constraints. This is the model part. And now we go to the solver part. We have to tell what solver we're going to use. In our case, we provide the Heist solver out of the box. So we specify that here by saying what the solver provider is. We initialize it, and we ask it to solve it. It's that easy. And then we can read out the value and report it or read it out and send it to our external system. And then in this case, the solution is 2 units of meal A and 3 units of meal B, which creates 27 units of happiness, the binkies. And it also reports there does not exist a better solution. You cannot create any solution which create more happiness. Okay, let's switch quickly to the screen. How this is actually implemented in this framework, the same framework as we've seen Sudoku and the router example. It's also a template that you can use yourself and you can adjust to your needs. We have input in the form of JSON. We can specify any type of meal here, so it's a little bit more generic than I just demonstrated. We have the code where we have specified the input. You can change that to your needs. It's very customizable. We build up the model, and it will create outputs when we run it. We invoke it exactly the same as we do with Sudoku and the router, which I will do now. It will create outputs. Obviously, that will be here in output. Let me format that. And then I'll go to the store part of the output where you can read out the solution. And it tells us, as we already know, 3 meals B, 2 meals B creates 27 units of happiness, and it was solved in 4 milliseconds. So obviously, this is a very small problem. It's a toy problem. Mixed integer problems, and the high solver can deal with tens of thousands of variables and constraints, and so therefore can be used for real-world problems.